Today we're going to use something called synthetic division, and I refer to it as the mama method, and that's only because we use multiplying and then adding, and then multiplying and then adding to achieve an answer. So we're going to start off with something really simple. I'm going to write down something that was more algebra based, like you would have seen during your freshman year. X squared minus 1x minus 6. If I gave you this function and I asked you to identify the solutions, there's a new way that we're learning today. Now, we learned that we can identify the solutions by solving using things like the factoring method. Sometimes that works. We could use the quadratic equation, which always works, right? We could use the completing the square method. We went through those different things. Now we're also going to involve the idea that sometimes we're going to get solutions that are complex and they involve i's. Now, how is synthetic division going to help? Okay, so you have this problem down. I want you to circle the last number. The last number is always going to represent, the factors of the last number will represent the numerator. So what numbers, I'm asking myself, what numbers nicely divide into 6? Can you grab me a calculator? So numbers that divide into 6. 1 divides into 6 nicely. 2 divides into 6. 3 divides into 6. 4 does not divide into 6 nicely. I want to give you an example if by hearing it, it does not make sense. So if I take and go 6 divided by 4, we can see that does not work. 6 divided by 5 does not work as well, so I'm not writing down, but 6 divided by 6 does give me a nice integer answer. So 1, 2, 3, and 6 are the factors of 6. It's the very last number. In the denominator, bless you, we're going to go over the factors of the leading coefficient. Well, the only numbers that divide into 1 would be 1. These are called possible. Everybody should be writing this down. You do not know this. Possible rational roots. These are possible rational roots. And now we're going to create a list of possibilities, possible roots, possible solutions. So 1 divided by 1, it could be, these are the possibilities. It could be 1 or negative 1, because positive 1 or negative 1. It could be 2 or negative 2. It could be 3 or negative 3, or it could be 6 or negative 6. And now we're going to test these. It's almost like how we have apps on our phone, or we even have apps now that we've learned about on the calculator, but instead of using an app, we're going to use our brain. And how we're going to test them is something that's called synthetic division. So what you're going to do right now is you're going to make an upside down division box. I'm going to use a color here to have it stand out. So make an upside down division box, and you want to make it fairly deep. And we're going to go through these one by one, and we're going to test. Please do me a favor, draw an arrow up here. This tells me we should have 2 solutions. I don't know what type of solutions they are. And you're like, what do you mean, what types? They could be real, no i's, or they could be complex, it contains i's. Okay, so the next thing we do is inside of here, I'm going to write these down, and everything has to be accounted for. So this is x to the second. This is x to the second. So 1x to the second. This is negative 1x to the first, and this is negative 6x to the 0. If you're like me and you are fairly sloppy, please make sure to try to be neat about this. Are you writing this down right now? Okay. All right, now we're going to test the very first one. So I'm going to put a 1 outside. And how we test this, and for some students this takes days to catch on to, other kids just maybe you want to watch and then you'll write it down afterwards. Here's what we're going to do. We always drop down the first number. So step 1, after I set it up, is going to be to drop down the first number. This is the magical number that we always go back to multiply to, whatever's on the outside. And you're like, how did I choose that number? I'm going through here and I'm testing these. We'll know if it tests and it works is if this number is a 0. Anything other than 0 in the end means it doesn't work. So here we go. You ready? I dropped it down, and now I'm going to follow mama. Multiply, add, and that's what we do. We just continue to do that pattern. So I multiply. This bottom number multiplies up here. This is always what we multiply to. So 1 times 1, I write it down. So I've multiplied, and now I add straight down. Negative 1 plus 1 is 0. Okay, bless you. Now I'm multiplying. I always multiply back to this magical number. 1 times 0 is 0. And now I add straight down, and I get a negative 6. And you're thinking like, well, what does that tell me? It tells me that 1 is not a solution. How do I know it's not a solution? Because I didn't receive a final answer of 0. So what do we do next? We're now going to test -1. So please make another upside down division box. And I'm going to write the exact same thing in. 1x squared, -1x the first, -6x 0. Everything has to be accounted for. And now I'm going to test the next number. I'm going to test -1. First step is always drop down. Bless you. I drop down the first number, and now everything gets multiplied back to this. So it goes multiply, add, and you just keep going until you get a final answer. Okay, here we go. Multiply. So -1 times 1 is -1. Add straight down. We're back to multiply. Multiply to get +2. Add straight down. Turn to your current partner. Does this answer represent that -1 is a solution or is not a solution? Turn to your partner. 5 seconds go. 5, 4, 3, 2, 1. It's not a solution because I didn't achieve 0. Come up here and cross out -1. Okay. So now I want you to set this up. So please do that. I want you to set this up. And I want you to test right now. Test +2. I'm going to press pause and I'm going to give you 30 seconds. As they're finishing up, I'm going to try this right now. I'm multiplying to get 2. I'm adding down to get 1. I'm multiplying to get 2. Does 2 work? Yes or no? Why does it not work? Because I didn't achieve a final answer of 0. I crossed it out. Okay, we're going to do the exact same thing with -2, but we're going to speed it up a little bit. So I'm writing it down. I'd like you to do the exact same thing. Always put a little box after the last one. I'm going to press pause. Let's check. I'm dropping down. I'm multiplying to get -2. I'm adding to get -3. I'm multiplying to get +6. I'm adding to get 0. It worked. It worked. How do I know it worked? It worked because I ended up with 0. So I tested -2. I'm circling -2. I'm going to have 2 solutions. I already know one of the solutions is -2. Now, how do I know -2 is not only a solution, it's a real root because it doesn't have an I. It's real. Now, how do we use this remaining answer? We can use this remaining answer to achieve the second solution. I know there's going to be 2 solutions. We can achieve the second solution. Okay, everybody write this down. There's 0, and we will actually work backwards. So instead of going left, right, we're going to go right to left. So 0 equals, this always has, the first one has no x's, so no x's. The second one has 1x. Ready? You have 10 seconds to solve for x. Most of you can do that in your head. Go. 10, 9, all right, so let's go over what we know right now. I'm going to come up here to the top. I'd like you to make, just like we did on Wednesday, make yourself an XY axis. And let's start with me actually just going over this to begin with. So I'm looking at the degree. The degree is 2. Is 2 even or odd? Even. So off to the side, I'm writing even. I know it's an even degree. Is the leading coefficient positive or negative? So I'm going to write degree is even, leading coefficient is positive. Turn to your partner using your arms as a way to describe the end behavior. What would even positive look like? What would even positive? It looks like somebody just scored a touchdown. Both hands are up. So I'm just doing this for myself. I know it's up on the left. I know it's up on the right. Okay? I've got that down. Also, I know the roots. One of them, look down here. One of the solutions, sorry, I didn't mean to hit that. One is 3, and the other is -2. So I'm circling those. 3 and -2. So please go to -2 on your makeshift graph, and please go to +3. And now, those are our solutions, are the x-intercepts. Sometimes solutions are not x-intercepts. That's when they are complex and they contain i's. But if they don't have an I, then our solution represents not only the real root, it represents the x-intercepts. Those are interchangeable words. The next thing we need to do is we need to identify what is the y-intercept. So this is really simple. Whenever we find the y-intercept, if you didn't know this, please write down x equals 0 below it. X equals 0. So I get to do just some simple math here. I know 0 squared is 0, 0 times 1. This is 0. 0 squared is 0, 0 times 1, right? That cancels out to 0. Negative 1 times 0 is 0, so I have 0, 0, minus 6. Turn to your partner. What is 0, 0, minus 6? Negative 6. So come down here to negative 6 and make a dot. Now, we already said it's going to be up on the left for end behavior and it's going to be up on the right. So watch. Up on the left, up on the right, come down here, and we are done. So we're going to start by listing all the possible rational roots. Well, how do we do that? Okay, first of all, we're going to list all of the factors of 18. So I'm going to give you a head start. That's always going to be in the numerator. So 1 nicely divides into 18. 2 nicely divides into 18. 3 does. 4 does not. If that doesn't make sense to you, watch really quickly. I come over here, I turn on my calculator, and when I take 18 divided by 4, notice I don't get a nice answer, a nice whole number. But if I take 18 divided by 5, I still have the same thing, a decimal. But 18 divided by 6 gives me a nice whole number. So 1, 2, 3, 6, bless you, 9, and 18. Those are all factors of 18. The leading coefficient is a hidden 1. So I'm going to list these out. Here are the possible rational roots. Please make sure you're doing the exact same thing. So I have 1 and negative 1, 2 and negative 2, 3 and negative 3, 6 and negative 6, 9 and negative 9, 18 and negative 18. Those are my possible rational roots. Okay, turn to your partner. How many solutions does this have? You have 5 seconds, go. Look at this original equation. How many solutions does it have? Brielle, how many solutions? There's 4. So come up here, everybody write 4. Everybody write 4. And I'm behind that, I'm going to write even. Because that gives me a little bit of a clue what the end behavior is going to be. So I wrote the number, the degree is the highest value on a variable in the exponent position. Now the leading coefficient is a positive number. Use your arms. What is this going to look like in the end? Go. What is this going to look like? Good. It's going to look both hands up. Okay, what I need to explain to you is this graph only graphs, these graphs here only graph real solutions. So if there is a complex solution that has an I, we don't see it. It's imaginary and it's hidden. All right, so our next goal is going to be to find these solutions. All right, are you ready? So let's get started here. Again, you may need to take out an additional piece of paper. You and your partner are going to work together as a team. When I say go, actually let me set you up with the first one here. Notice that this is to the 4th. So I have 1x to the 4th, negative 1x to the 3rd, 7x squared, negative 9x, bless you, and negative 18. And then I'm going to leave a little box at the very bottom. And if that results in a 0, then I know whatever I'm testing works. I'm going to do this twice. So let me write this out. You only have to write it down once to get started. You only have to write it down once. It's important to note that nothing is missing. And you're like, what is she talking about? So it's degree 4. I have some value to the 4th, some value to the 3rd, some value to the 2nd, to the 1st, and to the 0. When something's missing in the future, you're going to see what we're going to put it in place. Okay, are you ready? I want between you and your partner, unless your partner's like, I'm feeling really lost, I don't feel comfortable, then do them together. I want the taller person to test positive 1, and I want the shorter person to test negative 1. I'm going to do them at the same time, but I would like you to go ahead. Taller person test positive 1, see if it works. Shorter person test negative 1. And talk to your partner before you get started, because it's possible that your partner's like, I don't know what we're doing, can we do them together? That's just fine. Okay, I am testing 1. Everything multiplies back to here. So drop down, multiply to get 1, add down to get 0. Multiplying here to get 0, adding down to get 7. Multiplying to get 7, adding down to get negative 2. Multiplying to get negative 2. This is not 0, I cross out 1. Now I'm going to test negative 1. I drop down the first number and then I multiply to get negative 1, add down to get negative 2. Multiply to get 2, add down to get 9. Multiply to get negative 9, add down to get negative 18. Multiply to get positive 18, add down to get 0. I'm going to stop and wait. Now when I write this down, notice this, I'm going to test 2 next. It's my next number on my list. I'm going to write these numbers down. So I'm not putting down a 0. I'm going 1, negative 2, 9, and negative 18. And then I'm going to see, does this give me a 0? All right, I'm going to press pause, you and your partner. So here we go. You ready? Once I found one that works, I'm going to take the remainder down below and I'm going to continue to test. This is always my multiplying number. I am dropping down. So M-A-M-A, it's mama, M-A-M-A, and we just keep doing that pattern of M-A. So you ready? We drop down and now we multiply. 2 times 1 is 2. And I add straight down. Then I take that number and I multiply. 0 times anything is 0. And I add straight down. Then I multiply and I add straight down. Did it work? Yes or no? It worked. So I come up here and I circle positive 2. I'm going to ask one more time because I know she knows the answer and I think a lot of you may be a little lost. Look at this original equation, number 1. Using your fingers, how many solutions is this going to have? 4. How many do we know right now? We know 2. Now, once we get, so there's only 2 remaining, this is where we're going to go back to our Algebra 1-2 skills. You ready? We're going to write this out. 0 equals, and remember it always goes backwards. So it's always no x's, 1 x's, 2 x's, and it just continues to increase. So no x's, 1x, 2x. It always goes from now right to left instead of our normal left to right. Really quick, by the way, what's 0 times x? 0. So let's just go ahead and cross that out. And let's write down x squared plus 9 equals 0. Mr. Leone helped you to solve these about 2 weeks ago. So if we want to solve for x, what do we do with the 9? Subtract it to the opposite side. 0 minus 9 is negative 9. If we want to isolate the x, how do we get rid of the square? Okay, how many answers is this going to have? So I'm going to have 2 answers. Jade, can you take the square root of a negative value? Awesome, you moved it negative. Brian, do you remember what the negative becomes when we move it? An I. So I have plus or minus because I have 2 answers. The negative comes outside and it becomes an I. Some of you are going to just do this step in your head. By the way, what is the square root of 9? 3. So plus or minus 3i. We now have 4 solutions. So I'm going to write down the solutions. Let's see here. We tested one solution was negative 1. Another solution was 2. And then we have 3i and we have negative 3i. Those are our 4 solutions. Now I'm going to ask you to analyze those solutions. Are you ready? Of the 4 solutions, turn to your partner. Don't tell me, tell your partner. How many of them are real and how do you know that? You have 5 seconds to go. 5, 4, 3, 2, 1. Those real solutions are called real roots. Real solutions are also called x-intercepts. They're all interchangeable words. How many of them are called complex solutions? 2. How do you know? Because they have an I. Okay, it's time. Here we go. I'm going to make myself a little chart. Oh, I already have it up here. We're good. So I'm going to come up here and I'm going to, remember, real roots are like x-intercepts. So please go to negative 1 into positive 2. Negative 1 and positive 2. Now, a common question would be like, Miss Bradley, but where are we graphing the complex solutions? You can't. This only graphs real solutions. We can't graph those. All right, we know the x-intercepts. That's right here. We've identified those. We know our solutions. I'm going to write this in place. The solutions are x equals negative 1, positive 2, positive 3i, and negative 3i. The x-intercepts would be x equals negative 1 and x equals positive 2. I've already put those down. Okay, you ready? What is the quick way to find the y-intercept here? Turn to your partner. You have 10 seconds to go. 10. Talk to you. How do you find the y-intercept? 9. Talk to your partner. 8. 7. 6. To find the y-intercept, x is 0. So x0 here would make this 0, x0 here would make this 0, x0 here would make this 0, x0 here would make this 0. 0, 0, 0, 0. What do we have? Negative 18. Now, is it possible for me to draw this all the way down and go down to negative 18? Yeah, but this is just a rough sketch. So we're just going to go right down here. I'm going to write negative 18. Please do the same. Okay, you ready? Using your hands, we have degree 4. It's even. We have a leading coefficient is positive. What are our arms looking like for this? They're both up, so it's looking something like this. Up on the left, come down. I know it'd be much farther than this, and come back up like this. So I'm starting with possible rational roots of number 2. So I'm looking at the 12. Possible rational roots, what divides nicely into 12? Those are called factors. So 1 does, 2 does, 3 does, 4 does, 6 does, and 12 does. Leading coefficient is a 1. So at this time, I would like you to go ahead and write out those numbers. Positive 1, negative 1. So my possible rational roots would be plus or minus 1, plus or minus 2. I should write these out. I don't want to do it that way because I want to be able to cross them out. 1 or negative 1, 2 or negative 2, 3 or negative 3, 4 or negative 4. Let me zoom out here so you can continue to see the 6 or negative 6, 12 or negative 12. All right, this degree is a degree 4, which is an even number, and the leading coefficient is positive. I know I'm going to have 4 solutions based on the degree. Let's get started. Between you and your partner, I want you to decide who's going to test 1 and who's going to test negative 1, and then stop. So get it set up. Multiply to get negative 3, add down to get 4. Multiply to get 4, add down to get negative 12. Multiply to get negative 12, add down to get 0. Hands raised if you got 0 to work. Hands raised if you got 0 to work. Okay? So I'm going to come up here right now and I'm going to circle 0. That's one of my 4 solutions. I'm going to go ahead and I'm going to test negative 1 because it's already here, and then we'll move on to the next part. So give me 1 second. Drop down and multiply. And add, and multiply, and add, and multiply, and add, and multiply. Like, look up over here right now. Thumbs up or thumbs down? Thumbs up, it's necessary. Thumbs down, it's not necessary. Is it necessary for me to continue to add to these to get this number at this point? Yes, you need to do that, Miss Bradley, or no, you don't need to, and here's the reason why. Orlando, you hit a thumbs down. I agree with you. Why is that? That's it. It's not going to be 0. That's perfect. All I care about right now is if this is 0. And if I can look up there and go, that's not going to be 0, then I'm going to stop. I come up here and I cross out. How many more solutions do I need to find, kiddos? 3 more. Okay, you ready? Now, hold on this time before you get extra started here. We're going to test 2 and negative 2. But this time when I write them in, I'm going to go back to the one that just worked. So 1 worked. This is what I'm writing down. Not the 0, but 1, negative 3, 4, and negative 12. Okay, between you and your partner, please decide who's testing 2 and who's testing negative 2. Go ahead. Not work, so I'm going to use these same numbers, and now I'm going to test 3 and negative 3. I just tested 3 and I got 3 to work. I just tested 3 and I got 3 to work. Wherever you are, I want you to stop and look up here. I have 4 solutions. When I get down to this part, it's going to become pretty easy. So how is this easy? I want us to write this as an equation. 0 equals, remember it goes backwards, no x, 1x, 2x. So no x, 1x, 2x. What's 0 times x? 0. So 1x squared plus 4 equals 0. You and your partner have 30 seconds to solve that right now. You're picking up a pencil or pen and solving right now. Begin. Make sure you are talking to your partner. This should not be individualized. Two solutions here, so plus or minus. I can't take the square root of a negative. And the square root of 4 is going to be 2i. So I have solutions of 3 and of 1. The order you write them in doesn't matter. Of 2i and negative 2i. So I have 4 solutions. Of those 4, which ones are the x-intercepts? Only the ones that don't contain the i's. So let's come over here to 1 and to positive 3. And now we need to figure out what the y-intercept is. Turn to your partner. You have 10 seconds. How do you achieve the y-intercept? Go. X's become zeros. 0, 0, 0, 0. The y-intercept is at 12. Now, am I going to go way up here? I mean, could I count up 12? I'm sure I could count up 12, right? That would be somewhere way up here. No, that's about right. Okay? So when you have an even degree and a positive leading coefficient, what do your arms look like? Even degree, positive leading coefficient. They're both up. So I'm coming right through here and down and back up again. We are just doing a rough sketch of this.